Hey everyone, this video is going to cover functions, variables, and constants. You've probably learned about these back in your first calculus course or even in high school, so this won't be too difficult. These are the basics. We're going to first define what a function is. And a function is basically a rule that associates a y value for every x value. And you've probably seen this diagram used many times before, especially in your math courses. Basically two boxes. One is an input that we'll call x, and this is called the independent variable. And then, after you process it through a function, you end up with an output. Which we'll call y, and this is called the dependent variable. And as you learned in your calculus courses, your independent variable, or your input x, is going to exist in a domain, and your output, or dependent variable, is going to exist in a range of values. So when we're solving problems in electricity and magnetism, we're going to be using functions a lot because there's going to be tons of calculations. In calculating fields specifically, we'll be using functions to describe how the magnitude of a field is going to change with distance. And because fields are three-dimensional, in order to proceed with such calculations, we need to define three different points just on the coordinate system and around it. So, for future calculations, we must realize there are 3 points to consider. Let's first draw the coordinate system. So we have x, y, and z. Our first point is going to be the origin O. And this origin is basically the origin of the coordinate system where all values are 0. But then when we look at fields, there's also a physical object that we're looking at. So let's just say there's something we're looking at. It's represented by this shape. And this, we're going to define an arbitrary point A on this physical object. So let's call this point A. So this is our second important point. And last but not least, we now have our origin from the coordinate system. We have an arbitrary point on the object. We need to be able to make our observations from some point in space. And we're going to call that point in space P. So let's call that P over here. So number 3, a point P in space where we make our observations. Okay, so now we have 3 points. What do we do? We're going to take a look at the relationship between these points, where the variable r is used to represent the distance between them. So we can use the letter r to represent distance between points. So if we pick the line AP to be r, so let's say this is r, we have to realize that the lines OA and OP are not going to be the same, and we should probably give them a different name or a different subscript. So if the line AP is r, then OA and OP can be R1 and R2 respectively. So we have OA being R1 and OP being R2. So keep in mind, we don't have to use R, R1, and R2 exactly as we've written here. I can pick OA to be R, which means AP could be R1. So these are terms that we can use interchangeably. We just need to be able to realize that these 3 relationships and these 3 values are going to be different, and that means we can represent each point as a function of distance from each other. That's the main takeaway from this. So let's say we had a function like f of r1. So what if we had a function f of r1? So with the drawing we've shown here as an example, especially how we've labeled it, f of r1 is a function that depends on the distance between O and A. So we know it will be dependent upon the location of point A with respect to origin O. Okay, so hopefully that makes sense. We're now going to go through just a brief overview of derivatives and integrals, because you've taken calculus before, you would have covered how to calculate basic integrals and derivatives. So what's the difference? Just going to write down difference between derivatives and integrals. So the best way of explaining the difference between these two is to draw a function. So let's just draw our 2D coordinate system, and let's sketch any curve you want. We'll just go with something simple, and we'll call this f of x. Now, I have my function. What if I wanted to calculate the derivative at a certain point, or maybe an integral? We need to actually know what they mean in order to, number 1, do the calculation, and number 2, interpret what we've just calculated. So a derivative is where we calculate the slope of a curve at a specific point. So, such as at x equals a. So, if x is equal to a over here, it means we want to be able to figure out the slope at this exact point. And that slope will look like this in red, and that is called a derivative, represented by d over dx of our function. Now, what about an integral? So an integral is where we determine the area underneath the curve between 2 points. Such as x being between a and b. So this introduces a boundary condition. So now we want to be able to figure out the area underneath f of x between a and, let's say this is b. So between a and b, we'd have to figure out this area, and that is called an integral, represented by our integral sign, and it's the integral of f of x with respect to x, because this is along the x-axis. There is a boundary condition, so we must write down our lower and upper boundaries as well. So we have the integral of f of x with respect to x from a to b. So it is expected that you'll know how to work with derivatives and integrals in this course from your previous experience and knowledge. So next thing is to talk about constants. So looking at constants. This is one of the most common mistakes that students make, so we want to remind everyone to pay attention to what variables your function or operation depends on. So let's look at an example where we're trying to integrate the following. So just as a reminder, always look to see what variable you are working with respect to. So our example is going to be the integral from a to b of 1 over r dr. That means I want to be able to figure out the area underneath the curve of 1 over r from a to b. And we know that the derivative of ln of r is going to be 1 over r, so we know that the integral is ln of r. And we must integrate from a to b, so this is ln of b minus ln of a. In other words, this is ln of b over a, and that would be our answer. Now we compare to another integral. This one's very similar, but we've changed one of the values. So what about the integral from a to b of 1 over capital R dr? So now we've changed the 1 over little r to a 1 over big R, where r, or capital R, is a constant. So what do we now have? If we're trying to solve for this, we have the integral of the integral of 1 over capital R from a to b. So when we're approaching integrals, I'm integrating with respect to little r, which means everything else that isn't a little r is going to be a constant in terms of the integral that I'm working with. So if there is a constant, such as capital R, I take that out of the integral, and what's left is simply the integral of 1 with respect to dr. And so we now have 1 over r. The integral of 1 is simply just the variable itself. Just like if you derive x, it's just going to be 1, because 1 is in front of it. So we have r from a to b. That gives me 1 over capital R, b minus a. So it's a huge difference between the two examples we've just done. And obviously, if you go down the wrong path, you'll either get stuck or get the wrong answer. So always read the question first, understand what it's asking of you, and plan your approach carefully to avoid mistakes. Now, as part of the diagnostics quiz question, you had one that you can now solve with ease. So it's the one with the sine function that looks like this, where you had to integrate integrate sine of alpha from negative pi to pi with respect to theta. So when I look at this, the first thing I notice is what I'm integrating with respect to. I'm integrating with respect to theta, which means everything in the function that isn't theta is going to be considered a constant. So I have sine of alpha being my function. There's no theta in it whatsoever, so sine of alpha is a constant that I can take out. So this is equal to sine of alpha times the integral from negative pi to pi of d theta. Anytime you see that, the integral is just going to be the variable itself. So we have sine alpha times theta from negative pi to pi, which is equal to sine alpha pi minus pi, which is equal to 2 pi sine of alpha. So once you understand basic concepts, a lot of the questions become fairly straightforward to work through. A final thing about functions is their boundary conditions. So a note on boundary conditions. It simply means that if you have a function f of r, so if f of r is bounded by a and b, it means that this expression is only true for any values of r between the physical dimensions of a and b. And that means we can get the magnitude of the function at any point between a and b. And we do that by substituting the value for r with any value in between those physical dimensions.